Alrighty, I hope everybody enjoyed their lunch. Welcome back to the Forge preview track. We have a series of pretty awesome sessions this afternoon. Taking us away now is Tomek Sroka from the Platform Services team at Atlassian. So Platform Services build out a lot of the common platform components that are used by our cloud products. And today he's going to be talking about a couple of features that he was the feature lead on of the Forge platform. So product triggers, which allows you to respond to product events, and web triggers that allows you to respond to external events. And he's got some pretty cool demos he's going to be showing us as well. So I might welcome Tomek to the stage.
Thank you. I hope you all had a great lunch. My name is Tomek. I'm a software developer at Atlassian. And today I will show you how to use Forge to build applications that will automate some tasks in Atlassian cloud products. So if you use Jira or Confluence for your everyday work, you probably notice that some parts of your workflow are repetitive, manual, and can benefit from some automation. For example, maybe you want to create subtasks for each newly created issue and assign them to particular people based on some criteria. Or maybe you want to synchronize Confluence tasks with some external system used in your organization. And whatever the use case may be, when you start looking into how you can build such automation application, you may be a bit discouraged with what you find out. So in order to set everything up, you need some infrastructure, like servers, load balancers, and so on. You also need a way to deploy your application to that infrastructure, and if you want to make everything by the book, you probably need some monitoring to make sure your application is working correctly. And also you need to learn and implement lots of new things like authentication and authorization flow, which is quite complex. So it's really okay if you are writing a large application that's aimed at Atlassian marketplace. But if you are an in-house developer trying to automate a very specific use case, probably the work required to set everything up, requires order of magnitude more effort than just implementing business logic itself. However, Forge changes all that. So it adds exciting new capabilities on top of our cloud developer platform. For example, applications are hosted by Atlassian, so developers no longer need to take care about infrastructure at all. It also enables you to build user interfaces that work across web and mobile version of our products. And also it allows much more tighter integration with whole Atlassian ecosystem. For example, it takes care of the whole authorization flows, as well as it automatically authenticates API calls to Atlassian. So in this practical session, I will show you how to leverage different Forge features to build example automation app that will extend functionality of Jira. Sorry. So first, let me explain a use case for automation app. And in order to better do that, let me introduce my team at Atlassian, Platform Services. So our team builds various microservices that are used across different cloud products. For example, we built Stargate, which is an API gateway that powers api.atlassian.com. It helps us with things like authentication, authorization, rate limiting, and so on. Also, we built StreamHub, which is a distributed event bus that facilitates communication between different components in Atlassian. For example, when user creates a new ticket or edits a page, Confluence sends an event to StreamHub, and this event is delivered to all interested parties. One of them is indexer service, which reindexes the page and makes it searchable. The other is activity platform, which records all the user's actions and make them available through an API. Also, it allows Forge applications to react on events emitted by cloud applications. So we put a lot of effort to make those services reliable. However, things still can go wrong. For example, there might be network issue, or there might be programming error, or maybe unanticipated traffic spike. So we have a lot of monitoring around our services. We gather various metrics from infrastructure components like load balancers, servers, as well as services themselves. For example, we measure how long it takes to deliver event to all interested parties. And if this value is larger than our service level agreement, which is half a second, the alert will be raised. The other commonly used metrics are things like CPU usage, memory consumption, HTTP error rate, and so on. If anything looks out of ordinary, the alert will be created. But now, what happens with the alert? So we use Opsgenie product for the incident management. It helps us with scheduling and delivering notification to appropriate people. And we don't have any dedicated person that deals with the incidents. Instead, we've got a rotation. So each week, a different person is responsible for dealing with the incidents. And we say that this person is on call. So on-call person needs to have his cell phone always on hand and be within 5 minutes from a laptop and in a reasonable state because alerts can happen during the middle of the night as well. So once the alert is raised, Opsgenie pages the person and the on-call person has like 15 minutes to acknowledge it. If he doesn't do that, or if they don't do that, the alert gets escalated to other people, most often to the manager. So after acknowledging the alert, we can, the on-call person can start working on investigating the problem and hopefully fixing it. And aside from dealing with the incidents, we also need to support internal Atlassian teams that use our services. And Jira Service Desk is used for that. So if somebody wants to onboard our service or change configuration or have some general questions, they can go to our Service Desk project and raise a ticket and fill in all the details. And then this ticket should be worked on by somebody from our team. But who that person should be? So since we already have an on-call person that is on rotation, ideally we would like Jira to assign this ticket to this person and so he can start, or they can start working on it during the normal business hours. But also, people using our services can report incidents in case of there is any problem with our service. For example, our automated monitoring system may not have caught the issue, and Atlassian customers may be impacted. So in this case, if the incident is raised, we would like to alert on-call person immediately so he can start looking on this issue. So that's second thing we would like to automate, raise the Opsgenie alert once the incident is reported. And also the third thing related to that would be giving some feedback to the creator of the ticket so that they know that somebody is actively looking into their problem. To summarize, the application I'll be showing today will have the following 3 features. First, it will automatically assign all newly created tickets to a person that is currently on call. And then if the ticket is about a problem with a service and its severity is critical, which means Atlassian customers are impacted, the person on call should be alerted. And when the on-call person acknowledges the alert, tickets should be commented with the information that somebody is working on it and who that is. So let's see how the first feature can be implemented. So for each new ticket, we need to go to Opsgenie and get the email of a user that is currently on call. Then we need to translate this email to Atlassian user ID, and we can use a Jira API call to do that. And finally, we can call Jira API to assign newly created issue to that user. So it's quite a small thing, just a free API calls. So let's look how we can implement that with Forge. So before we get started, we need 2 prerequisites installed on our machines, namely Node.js at version at least 12 and Node Package Manager. Once we have them, we can use npm to install a Forge command line tool, and this is the main interface for developing Forge applications. And it allows us to do things like creating new apps, deploy, install, view logs, and many other things. Then we can log in using our credentials and create our first applications. Once we run these 3 commands, we can start working on our application. So let's just have a quick look at the insides of Forge application. The main file describing the whole application is the manifest. It's just a YAML file containing some metadata about the application. It also contains different modules. The main module, the very basic one, is a function, and it's just a reference to source file and the method. Then there are other modules that builds upon that. There is a macro module, which executes the function to render user interface. There is a trigger or product trigger module that executes function if some events happen in Atlassian cloud products. And also there is a web trigger module, which allows to react on events or webhooks generated from external applications like GitHub. So here is an example hello world function. It doesn't do much. If your function is to be invoked by Forge, you need to export it and also declare in manifest. So the Forge requires functions to be written in JavaScript. But since there are many languages that just compiles to it, you don't have to use it if you don't want to. But still, JavaScript or TypeScript are the most supported use case, so we recommend using that. And it's also worth mentioning that your function is executed in constrained environment. So this is like not a full Node.js runtime. For example, your function cannot access file system or use native libraries. And this is done to ensure proper isolations between different Forge applications and to make sure that there is no any malicious behavior. Also, there is constraint on how long your function can execute. Currently, it's 10 seconds, so if your function doesn't finish within 10 seconds, it will be terminated. And runtime itself also provides some basic building blocks that makes it easier to work the whole Atlassian ecosystem. For example, it automatically authenticates API calls to Atlassian. So before your app starts working, it needs to be installed into site and the product. So you need to run Forge install command, and from now on, this site will your application can start receiving events from the site or showing user interface, and so on. But what if you want to have different versions of your application installed on different sites? For example, you may have some bleeding edge version with some experimental features where you want to test it, and you want to have a stable version of your application which is installed on your production site. So Forge provides three environments by default: development, staging, and production. And each of those environments can have different versions of your app deployed. Those environments can be associated with different sites. So if you deploy a new version just to development environment, in this example, only Dev1 and Dev2 sites will be affected. And once you're happy with testing, you can promote your version to different environments. And as Tim mentioned during the keynote, you will also be able to create your own environments. So now let's see how functions can respond to various events. To do that, we need to use product triggers, and here is a simplified diagram of how that works. So when user makes some action, maybe they modify the page, the event gets sent to event batch, which is a stream hub. Then the event is delivered to trigger service, and trigger service is able to determine which applications are interested in this event and invokes appropriate functions with the payload of the event as an argument. There are over 20 different events. Some of them are common to Jira and Confluence, some of them are specific. And your application needs to declare explicitly which events it is interested in. And depending how you want to structure your application, there might be a different function handling each event, or there might be one function handling all of them. So now let's see what the event looks like. So the format of the event is the same regardless of its type. First, we've got account ID, which is standard Atlassian user ID. And this can be like a real human or just an app account. And if you want to know more, things like email, display name, and so on, you need to do additional API call to identity. Then we've got the timestamp of when the event was created and what type it was. And we've got object on which action was performed. And in this case, it's an example of issue created event, so the object is really an issue. We've got a local resource ID, which is ID that can be used to call a Jira API to make some action on the issue. For example, we may use it to assign issue to somebody or to comment on the issue. We've got a name, which really is a title of the issue. We've got product from which it was in which it was created. Cloud ID, which is just the site identifier used in Atlassian, as well as very handy URL of the issue itself, which we're going to use in this automation application. Also, we've got containers, which tell us about the hierarchy of the object. So the top-level container is always the site, and in this case, it's a product fabric internal instance used by Atlassian. And also, we've got project in which issue was created. So this is very important because we can use it to filter out events we are not interested in. For example, our automation project may be only enabled in certain projects, and other projects should be left alone. And finally, we've got contributors, and this is just a list of accounts ID that ever made any changes to the object. And so with this information presented so far, we'll be able to implement the first two features of the application, namely assigning issues to person currently on call and raising the alert in Ops.Genie. So I'm not going to walk you through all the code. I'm just going to concentrate on more interesting snippets. So the first thing we need to do is we need to get on-call person from Ops.Genie. And in order to do that, we need two things. Schedule ID, because there can be many different schedules used by different teams. And also we need an API key. So before I mentioned that runtime provides a way of automatically authenticated requests to Atlassian API. However, Ops.Genie is not yet well integrated with the whole Atlassian ecosystem. So we need to treat it as any external application. So to not hard code this API token, we're going to use environment variables, which is another feature of Forge. So we can set the value of this variable using the command line, and then a function can retrieve this value at runtime. Then we're going to pass this to the function that fetches the on-call person. And this is implementation of that. So we're just going to use api.fetch, which is a standard fetch method, also available in browser, and we're going to put this authorization header to authenticate our request. And then it's just a matter of parsing the response and extracting the proper email. Making a request to Jira is simpler because we don't have to do any authentication. We can just call the API directly using api.asApp. And this will authenticate our request as a current app user. Okay, so this is how we generally will implement these two features, just a bunch of API calls. But how about the third one, which is we need to comment on the issue once the Ops.Genie alert is acknowledged. And we cannot use product triggers for that because, again, Ops.Genie is not yet integrated well with Atlassian ecosystem. So to receive, events or webhooks from external products, we need to use web triggers. So many products like GitHub, PagerDuty, and others allows you to configure webhook. And webhook is a way of notifying integration, in this case Forge applications, when some event happens. For example, somebody may create a pull request in GitHub. So when the event is triggered, application will make a request to URL defined by us, and will send the details about the event itself. The request will go to trigger service, and it will invoke a specific function and application that is interested in the webhook. And this URL is generated by Forge. So what does the function receive when this URL is called? The details of the webhooks are not very well defined, and they are specific to app vendor. That's why web triggers needs to be very generic. So function receives the whole HTTP request that was sent by the product, which means method, headers, body, and path, and function needs to make sense of this data. And there is a similar thing with the response, because the details of what the product expects as a response, it's totally like app vendor specific. The function needs to return the whole HTTP response, which means headers, status code, and body. Usually, it's just enough to send status code 200, which is OK. And here is a very basic web trigger function. It just responds with OK status code and echoes back the request body that was sent to it. We can even use browser to call this function and see some results, which I will show in a second. And in order for our web trigger to work, we need to declare our handler function in manifest, as well as the web trigger element itself. And once we have that in the manifest, we can use Forge web trigger command to generate a URL. So you need to provide product and site URL because each function is executed in the site and product contexts, and also for which web trigger the URL is generated. And you can see generated URL at the bottom. And if you are wondering why it's so long and ugly, I can assure you we are working on that, and it won't look like this in the future. Once you have a webhook, you can just go to Opsgenie or any other application and configure it. In this case, we want to Opsgenie to call our URL once the alert is acknowledged. Okay. And before I will proceed to demo, I just quickly wanted to mention some things under the covers that you should be aware of when writing Forge applications. So the first thing is function triggering itself. So the very artificial and simplistic example would be the function that responds to commented issue event. And in response to that, it will just post another comment to the issue, which again will trigger a commented issue event, which will trigger a function, and so on and so forth. So we will have this never-ending cycle. What will happen in practice, after 50 or so comments, your function will get rate limited and will be blacklisted for some period of time, which means it stops receiving events. So the easiest way to work around it would be just checking of the user that created this event and comparing it with the app's own user and just rejecting such events or ignoring them. But it's not always the case. Sometimes you may be interested in your own app events, so then you need to make sure that this cycle never happens. And the other things to be aware of in product triggers are caused by the complexity of distributed system. So before a function receives the event, there are many hops along the way. So many different services are involved in passing and transforming the event. And many things can go wrong. For example, service that translates the events to common format may be at capacity and may be delaying the events. So this may cause delays. So instead of a function receiving the event within less than a second after it happened, it might receive it after 10 minutes. Also, the events might be delivered out of order. So for the same page, you may first receive update page event and then create page. And also, your function may be invoked with the exactly same event multiple times. And to deal with that, we can have different strategies employed. So those things are not happening very often. There are very rare scenarios, but still, the application should be built with them in mind. So for example, to deal with the delays, we can just reject old events, like older than 5 minutes or 10 minutes, depending on our use case. In the Opsgenie automation case, we can check if the issue was not already assigned to someone, so that we don't override this assigning, because maybe it was manually assigned by some other user. To deal with duplicates or to avoid doing same thing twice, we can check if the action that we are about to perform was not performed before. So again, in the Opsgenie case, we can check if we haven't raised the alert already for the same issue. And a few words about the web triggers. So web triggers may generally suffer from exactly the same issues, because all these external products out there are also distributed system, and they may occasionally have some glitches. But also a very important thing about web triggers is authenticating them. So the web trigger URL is not secret, right? It can be logged in several logs. You can just paste it on Slack or pass it to support. And if this URL comes into the hand of some malicious party, they can start invoking our functions with some fake data. So in order to ensure that the webhook was sent by the GitHub or whoever, we need to authenticate the request. And unfortunately, there is no one standard way of doing that. It's very specific to the vendor. For example, GitHub uses hash-based message authentication codes. So you have a secret that is shared only with GitHub and your application, and then GitHub computes hash code based on the secret and the payload that it sends to you. Then your function needs to do exactly the same computation and compare the values. If they match, it means that the message is authentic or that your secret was stolen. In Opsgenie case, we can add additional header to the request that is sent to the function, which contains some secret, and then we can compare this header with the secret we have in an environment variable. Okay, so that's pretty much it. Let me show you the demo of the application of how it all works. So I created an example service desk project, and we can go here and create, for example, and go and. Sorry about that. Okay. So this is a service desk project that is used for the sample application. So we can go here and, for example, create a new request to onboard us. So once I create this ticket, it should be assigned to the person that is currently on call. So if we go to OpsGenie, it is currently myself. So let's see what will happen. Okay. So after some time, this ticket should have been assigned to myself. And you can also see who did that in the history log. Yeah, it was done by my application. You can also check out the logs, what happened. So this command will show me the last invocation, the logs of the last invocation, so we can see that our function was called, we determined who the on-call person is, and that the issue was assigned. So the other feature I want to show you is how to raise the alert in OpsGenie. So for that, I'm just going to change the person currently on call, and I'm going to set team. Oh, not this.
Uh-oh.
As a person currently on call.
You sure about this?
All right, so team is currently on call, and now we are having some critical issue with one of our services. So let's raise a ticket for that.
Apparently my on-call schedule rotation is starting.
Yeah. We're just gonna say that our service is critical, because only then the alert will be raised. Which service is impacted, add some details. And we're gonna send a request. So after some time, hopefully the on-call person will be paged. Yes.
Hey.
So he was paged. Also the issue was assigned to Tim. And what he saw on his cell phone was something like this.
Actually, do you want to verify? Hold on. Can you read this alert for me?
Please help. Yes, it was assigned to you.
Right. So also what Tim has is a very handy URL to the issue, so he can go directly to the ticket from OpsGenie. And once Tim clicks acknowledge, we should see
Acknowledged.
acknowledged. We should see a comment on this issue. Yeah. Made by our app, saying that somebody is looking into this problem actively.
Woo.
Okay. So, thank you. I'm really glad this live demo worked. Also, I just want to show you something about web triggers. So web triggers can be used for many different things. It don't have to be for webhooks, because they are very generic, so they receive the whole HTTP request and can respond with even HTML. So if you start playing around with it, you can write a web trigger that will return just some HTML or even accept form data, and so on. So let's see how this may work. So here I'm just gonna generate the web trigger URL for this function, which returns me HTML. So here's this ugly URL, and we can open it in the browser and see it. That's the HTML that was generated by web trigger. So they have many different use cases, but this is not intended use case, and probably in the future we will add something specific for that in Forge. So this is pretty much it. Thank you for attending. I hope I convinced you to give Forge a try. Yeah, thanks.
Awesome. Thanks, Tomek, and thanks for the live demo. We have an internal poll running to see how long it'll be before the first Atlassian feature team is building apps purely on Forge. So kind of cool to see an Opsgenie Jira integration. So we've got a few minutes for questions. Any questions from the audience? Cool. Okay. Thanks again, Tomek.
There was a question.
Oh, there was? Oh, sorry. Hold your applause.
Thank you. It's just a curiosity question because for the function part or for the code execution, it's transparent that this runs on AWS Lambda. So this implementation detail, even though we do not need to care about it, is at least it's in the open. I wonder whether this triggers what your event bus is based upon. Is this based on AWS CloudWatch events? It's an event bridge?
No. So we have a service that receives the webhooks, and this service just executes the function directly on Lambda. So it's not CloudWatch based or anything.
Awesome. Any other questions? Oh, perfect.
What about transactions?
Transactions, no, we don't have any support for that. I don't think there is support for that in Jira or Confluence APIs as well. At least not yet. Maybe in the future.
Yeah, transactions are a difficult one while we're limited to REST APIs. So I guess there are transactions happening in Jira within each update, but you'd probably be best to look for some of our batch update APIs and use those atomically rather than, I don't think we have a good way to batch a set of REST API updates together into a single transaction.
If you've got, my thinking is if you've got critical actions and if an event is not transactional, which means what happens if an event is lost and in terms of a critical action, then nothing has been done.
So it wouldn't be the case. So event is never lost, to be honest. What you will receive is you can receive duplicate events. Just because of that, we want to make sure that you receive event at least once. So the worst thing that can happen, you may do the same action twice or thrice.
Interestingly, one of the services that's powering product triggers under the hood is a new service that's being built out called the Activity Platform, which actually has a GraphQL API for querying activity as well. So this is where you can subscribe to events, but we will have other ways for you to poll activity later on as well. So if you want to be doubly sure or get activity after the fact, there will be other mechanisms to do that. In fact, Sergey Meshkov at the end of the hall is going to have a talk on the Activity Platform a little later today. What time's your session? 4:50. Okay, fantastic. So 4:50 p.m. If you're keen and want to learn more about Activity Platform, definitely check that out. Oh, got a question at the front.
Hi, I'm just curious. I was speaking to someone who was giving Forge a try, and they were wondering if they could access the query string parameters in the web trigger, and whether that's something, if you can't do it now, if you might add support.
So yeah, queries, that's a bug. We're going to pass them for the function as well. So you'll get access to the full request, including query string parameters.
Awesome. Okay, if that's it for questions, thanks again, Tomek.
Thank you very much.